Jeremy, you have the floor.
Thank you very much, Raw. Could I have the next slide and the next one, please? So, in his introduction, Raw gave us a quick reminder of what the business priorities we have in EUMETNET are for data sharing. On the right-hand side, I've listed them here again. So we know we need to comply with the EU Open Data Directive and the high-value datasets implementing regulation, API access, machine-readable APIs, and so on and forth. But in previous workshops, we also talked about increasing the exploitation of our data and delivering wider value to the wider community. We wanted to be more agile and responsive in how we collaborate with data sharing. We wanted to increase recognition of NMHS as an authoritative provider, essentially by making our data more visible in the community. We wanted to avoid duplicating effort amongst ourselves, so if we can work together to deliver these kind of activities, we should do that. We wanted to improve decision-making downstream by having the right data available to people at the right time, and so on and so forth. I thought it was also interesting to provide a view on the WMO business priorities for data sharing. Within WMO, there's a desire to support all of the WMO programs and UN initiatives such as Sustainable Development Goals, the Paris Climate Change Accords, and the Sendai Disaster Risk Reduction Framework. We know in WMO, we've signed up to the WMO Unified Data Policy, and WMO reform drives a new Earth system approach, so looking at data across more domains. We need to enable the Global Basin Observing Network, GBON, respond to emerging data issues that were shared, I guess, back in 2018. And there's a recognition in general that big data is coming to us all. The data volumes are growing, the speed at which we create data. All of that is happening to us. And within WMO, we know we need to use that big data to help us to provide the best services we can to citizens. Next slide, please. So within EUMETNET, we create this thing called FEMDI, and within WMO, we have this thing called WIS2. It says here that WIS2 is a collaborative system of systems using web architecture and open standards to provide simple and timely and seamless sharing of trusted weather, water, and climate data. In the bottom here, open standards, web technology, cloud ready, and replacing the GTS. I'm not going to go into the details about why the GTS needs to be replaced, but you can ask me later if you like. All of those things are equally valid in terms of the things we're trying to achieve through EUMETNET with our data sharing and with the creation of FEMDI. So FEMDI builds on and extends what we've done in WIS2. FEMDI is a federated approach to sharing our European meteorological data, and it will provide a unified view of all the data available from members and collaborating organizations. The shared parts of FEMDI will be operated by our members on behalf of the community. And I think it's really important to state that FEMDI enables WIS2 implementation in Europe, because FEMDI builds on and extends that WIS2. Next slide, please. So if we were to understand, I think, FEMDI, what we need to do is understand a little bit more about WIS2 WIS2 first. Some of you may have seen this if you're at INFCOM, but I'm just going to quickly run through the core concepts associated with WIS2. So first of all, central to WIS2 is the concept of a WIS2 node. These are used by national centres and data collection and production centres, that's the things that we operate, to publish their core and recommended data. Next. Principle 1 of WIS talks about adoption of web technology and open standards. So that means that WIS2 can be implemented using freely available components like the WIS2 box that we'll talk about later, and common industry practice. And simply put, WIS2 nodes publish their data as files on a web server or using an interactive web service. Next. And because security and access control is baked into web technologies, you can decide how you want to control access to your data. Next. Okay, now recognizing the potential high demand placed on a WIS2 node to serve data to a global audience, WIS2 provides highly available, highly performant global services to ensure that WIS2 meets the required performance levels. Next. A component called a global cache is used to distribute copies of WIS2 nodes, copies of data downloaded from WIS2 nodes of real-time or near real-time core data. There will be more than one global cache around the world to make sure that we have adequate coverage. Next, please. Data consumers should download from the global cache if they can to make sure that we don't overload people's WIS nodes. Next. And to ensure that a global cache can meet its service level expectations, so for example, we know that as institutional users, we have to deliver safety critical services, so we need to make sure that data is accessible when we need it. A global cache may restrict access during periods of high demand in accordance with a fair usage policy. Next, please. So when new data becomes available at the WIS2 node, it generates a notification message to advertise data availability, and it publishes that on a message broker. Next, please. The notification message gets published to a highly available, highly performant global broker, and there will be several of these dotted around the world as well, that republishes the message for global consumption. Next, please. Also note that the global cache uses that same notification mechanism to trigger when it needs to download a copy into its cache. Next, please. The information in the notification message tells the data consumer where they can download the data from. So the message is what tells you what you need to download. Next, please. So how do people know what messages they need? Data consumers subscribe to topics at the global broker so that the notification messages for that topic are immediately sent to them. Next, please. There's a unique topic for each data set, and the topic structure is organized according to the way that the unified data policy is structured. Next, please. And the same mechanism and topic structure are used by the global broker so that it can republish notification messages from all WIS2 nodes. Next, please. So data publishers, again, that's mostly us, we create discovery metadata, and that describes the data sets that they make available through WIS. Next, please. And these metadata records are collected and published at the Global Discovery Catalog. Next, please. The data consumer can search and browse the Global Discovery Catalog to find the data sets they need. And again, the Global Discovery Catalog organizes the data sets according to the same standard scheme used in the topic hierarchy for the message brokers. Next, please. The discovery metadata tells data consumers where they can download data and where they can subscribe to notifications about new data. Next, please. So finally, with WIS2, there's a component called the Global Monitor Service that will track what data is made available and whether that data can effectively be accessed by the data consumers. So it's monitoring both data availability and service performance. Next, please. The global monitor will provide a dashboard that will track compliance against the unified policy and GBON technical regulations. And I think that's all we have to say about WIS2. So next slide, please. What I want to do now is to map those concepts of WIS2 onto what FEMDI looks like, so we can see those things and see where things join up. So next, please. This diagram you will have seen before. It's I think we've used it at previous workshops, and it's certainly used extensively in our FEMDI comms materials. Next, please. So first of all, obviously, data consumer is data consumer. Next, please. The WIS2 node maps onto the capabilities provided by data publishers down in the bottom of the diagram. Next, please. The message broker in FEMDI will be WIS2 global broker, and we've been in discussion with Meteo France, and Meteo France are going to provide a WIS2 global broker, and that can be reused to support FEMDI. Next, please. The data catalog is the same technology and uses the same standards as the global discovery catalog for WIS2, but it's likely that we'll need a separate instance of that, and I'll come to that in a moment. Next, please. The global monitor partially maps on to what we talk about with our insight service. So the insight service is intended to help people understand trends and future predictions about how and why people might use data, whereas the global monitor is just tracking performance and data availability as it happens. So there's a partial mapping there. And then finally, next, please. WIS2 has the global cache component, but FEMDI doesn't include this function. WIS2 uses the global cache to provide highly available, highly performant access to real-time and near real-time core data. But you've got to note that the global cache in WIS2 doesn't host any non-real-time data. So no recommended data goes into the global cache. FEMDI, principle number 10, that we decided, 18 months ago, says that FEMDI will provide access to data holdings in situ where local capability exists to do so. Moving data to a remote system only to support data sharing should be avoided. So by design, we've tried to avoid the need for centralized storage and a global cache, and I will come back to this in the next slide or so. Next, please. So here we are. Let's just take a look as to how FEMDI extends WIS2. I call it WIS2 plus, but that doesn't really make much sense to most people. So FEMDI is extending WIS2 in a bunch of different ways. So first, FEMDI provides unified access to data from all of our members, all the EUMETNET members and cooperating organizations. WIS2 provides access to data from individual places, individual organizations, where we're trying to find, as Raw said, that one-stop shop, that single front door to all of our data. The second point is that is around data access via standards-based interactive web services, so that we can be HVD ready. WIS2 sets a minimum requirement to publish files on a web server, plus notifications identifying that those files are ready to download. And this enables existing file-based data exchange models to be maintained. This is the way we work today with the GTS. FEMDI aims to use interactive web services that many of us have already been using to share large and complex data sets. And FEMDI will drive consensus around the web service APIs that are to be used, such as the OGC Open Geospatial Consortium EDR APIs. WIS2 doesn't specify any particular web service standards, only that if you do use an API, they should be self-describing. Number 3, data usage insights. WIS2 provides a basic framework for capturing metrics about service performance and data availability, whereas in FEMDI, we have the API management function that will also capture richer metrics about who is using the data. And so FEMDI applies analytics to those metrics to determine insights about how and possibly why data consumers are using those data, and those insights can be leveraged by us, EUMETNET members, to help us build better, more valuable services for future iterations of FEMDI. Next up, number 4, we have managed access to data and data service optimization. So by design, as I said earlier, FEMDI avoids the need for components such as WIS2 Global Cache with centralized storage. And we do this first by supporting its members in designing and operating robust data services, so those down at the bottom half of the diagram. Second, the European Weather Cloud and public clouds complement our on-premise infrastructure, where the data services are deployed. So in Europe, we have robust infrastructure that we can build on. And thirdly, we protect those data services from exceptional and possibly crippling loading using API management. So we ensure that we can maintain agreed levels of service for ourselves and other data consumers. Quickly going through the rest of the list, we will have some EUMETNET specific governance and data management workflows because we will want to operate in a slightly different way. We want to extend the data scope beyond the WMO Unified Data Policy. And that's one of the reasons that we need our own instance of the data catalog. Number 7, there's the possibility that we could provide European specific language and locales. WMO has its 6 official languages. There's a lot more than that in Europe. In the future, we will have integrated computation services for working with big data. And finally, we have the possibility to include third-party data from the private sector. So WIS2 gets us a long way down the track, but I think it's FEMDI that finishes that journey and enables us to deliver the one-stop shop that Roy just mentioned. Next slide, please. So here is the one-stop shop. We have roles such as data publishers. Next, please. And data consumers, and that will include NHS, industry, search engines, and the public. Next. So the first step is that data publishers, that's the bottom half of the diagram, you publish your data and metadata to the FEMDI data catalog. Next. Data consumers can see the data that's available, search the metadata, and subscribe to receive updates when new data is available. Next. Data consumers can submit a request for data or a computational workflow that needs for some bespoke data processing. Next. FEMDI looks at the request and may send out multiple requests to individual data services. Next, the local data or computation service components process the request and return the data back to the FEMDI community component. Next, please. And then number 6, FEMDI packages that response and returns them back to the data consumer. And then finally, number 7, data publishers then receive data and service usage metrics, so we can figure out how to improve the services going forward, and we can show the value of how people are using data. Next, please. So I just wanted to remind ourselves about the data sets that FEMDI is covering. So FEMDI, if you like, is an overarching coordination mechanism through which we will provide access to a number of data sets. Some of those data sets are HVDs, and many of those HVDs are covered by radio. So we have warnings, climate observations, digitized and undigitized historical climate data, radar data, and surface land observations. NWP is an HVD, but isn't in the scope of radio, so we're going to have to do some additional work around that. And then we have other data such as climate predictions, phenology, other observations such as marine stuff. So there's a pretty broad scope of data that we're trying to make available. Next, please. In order for FEMDI to work, we need a collection of technical governance policies, standards, and processes to make that work. We often call this PSPs, policies, standards, and processes. Next. The technical PSPs, they focus on interoperability, trust, and data value. Next, please. And then the governance PSPs refer to things like overarching cooperation agreements, SLAs, how we maintain FEMDI going forward. Next, please. The FEMDI operating model will ensure, so this is basically a description of the way that we want to work, and this operating model will ensure that the services that we provide are reliable, operated effectively, and developed appropriately. And this is how we will make sure that FEMDI can be depended on by EUMETNET members to share and consume the data and products that we need. Now, the operating model is still a work in progress, and it will continue to be developed over the coming year in the radio project. Next, please. If we break things down into components, so how do we implement this federated solution? The top half of the diagram, I talk about community components, and these are needed to deliver shared capabilities, such as the data catalog or access management. These will be established and operated by EUMETNET or its members, and they will be usable by data publishers and data consumers both inside and outside the meteorological community. Next, please. Then we have what we call local components, and they're local in the sense that they're local to you. They integrate with the community components to enable data discovery, data access, and notifications to users about availability of new data sets. And these are established and operated by individual organizations such as Met Office, Meteo-hydrological, KNMI, ECMWF, etc. Next, please. Just to touch on FEMDI roles, next, please. So the data consumer, these are entities, organizations, individuals, or IT applications that consume data. Next, please. We have capability operators, both for local and community capabilities, and these are entities providing an operating infrastructure to allow for data to be discovered and shared. They will provide support services for managing access to the services that they're responsible for. It's important to say that the operators are free to choose the appropriate technology for the things that they do. FEMDI says what those things need to do, but it doesn't say how you do that. Data owners, these are the people who are responsible. They own the data and they have the authority to decide how their data is used through rights, obligations, terms and conditions, etc. The data publisher is the person that collects and shares the data with consumers in line with those FEMDI terms and conditions. And this role may be the data owner. They may do it on behalf of the data owner. They may provide the technical means for the data owner to enable data sharing with other participants. And then finally, next please, an important role, not to be forgotten, is the FEMDI program team, which will be a central team that coordinates and governs FEMDI operations, including all the top level components in the operating model. Next, please. If we look in community components, we have a shared data catalog, we have a message broker, we have identity and access management to control user and system access to the platforms and platform services. We have API management that provides the interface between data consumers and the underlying data stores. And allowing or enabling managed access and usage of data and products. We will have computation services in the future, excuse me, enabling users to process data close to the data, and the Insights service, reporting on data discovery and publication transactions for data publishers, so that we can figure out insights about how people are using data. So it will provide management information. Next, please. And then if we look at local components, there are 5 core things that are going on here. So these are the things that most of us will have to build. A notification service. We'll need to do metadata management to create, publish, and maintain the discovery metadata. We'll need to do data access to expose data to FEMDI users using APIs through the API manager. And then there will be data processing to standardize and productize data so it can be shared. So, for example, that might be converting it into the right format. And then finally, there will need to be persistence, data persistence, to store the data that you want to share. Next slide, please. If we look, just take a little deep dive into the local components, the data supply capability will be used by us to share data with FEMDI consumers. It has those 5 core components that I just talked about. If we look at point number 2, the shared data catalog will be used to catalog data and data products that we're sharing. It will store the discovery metadata needed to discover what we provide. Number 3, the FEMDI users will be able to access shared data via APIs through the API manager. Number 4, changes to the discovery metadata and availability of new data sets will be notified to the user via the message broker. And in the future, we'll provide these computational services to enable users to process data close to the data. I'll touch on that at the end of the presentation. Next, please. So when it comes to notifications, these are used to update people about changes to discovery metadata and the availability of new data itself. For example, a new buffer message has been made available. The data supply capability needs to integrate with the message broker to send notifications to FEMDI consumers about new data. The message broker operator will need to configure the service to receive notifications, or rather subscribe to notifications from the local components. And the shared catalog is responsible for keeping users up to date. But let's just skip on that one. Next, please. In terms of metadata management, to facilitate the discovery of shared data, data publishers need to provide discovery metadata and share it with FEMDI consumers via the catalog. The discovery metadata should describe the source of the data and provide a link to the detailed provenance and lineage information, which could be a hyperlink to a HTML web page. Data publishers are free to choose a suitable solution to manage their metadata, but they do need to ensure that the metadata is always up to date and that the shared catalog is updated in a timely fashion. And the discovery metadata changes are notified through the message broker to the shared catalog, which automatically applies those updates. Next, please. When it comes to API management, we talk about data being accessed through APIs. When we plan to share data through FEMDI, data publishers need to ensure that their local data supply capability is integrated or configured with the API manager. It's assumed that data formats for data exchange will include enough metadata to interpret the data which is exchanged. The API management service operator will need to configure the service to expose the APIs that each data supply capability offers, and the procedures and protocols that the data supply operator and the API manager, how they share their information. that will depend on the solution that's built, and that's planned for Rodeo Work Package 2. Next slide, please. So, EUMETNET members, we've all committed to implement WIS2 already. The data supply capability will enable EUMETNET members to support both WIS2 and FEMDI. So, as shown in blue, most of the FEMDI data components, data supply capability components, are also required for WIS2. The main differences around the data exchange mechanism. I already talked about that, so I'll skip over this. But essentially, FEMDI promotes interactive web services. WIS2 sets a minimum bar of file-based data exchange. Both still need to exchange data in compliance with the appropriate policies and standards. But when FEMDI data publishers are considering delivering their data supply capability, I think it's important to see this as enabling both WIS2 and FEMDI at the same time, not a separate requirement. Next slide, please. There is an open source implementation that people can use and pick up, and we'll hear about that later in the one of the case studies. But essentially, it's open source, coordinated, development coordinated by WS Secretariat, with a 1.0 release scheduled for December. So that's next month. Next slide, please. Just as a couple of examples, we've been through trying to identify the requirements for the next program period, 2024 to 2028, and understanding how FEMDI affects how these things work. So my first example is EASAP, and you can see that one of their tasks around EASAP is to make sure that the data is inserted into the GTS. So as participating members migrate from GTS to WIS2, the members' WIS2 nodes can be used to share data with FEMDI. So basically, EASAP data shared via WIS2 will be accessible via FEMDI2, and so there's no additional program requirement there. We can see I've just included some excerpts from the spreadsheets that the drafting team have been working up. Next slide, please. EGVAP is very, very similar. In this case, we're talking about ZTD data, Zenith total delay. In the case of EGVAP, the Met Office operate a data hub, and as the Met Office migrates from GTS to WIS2, the Met Office will be able to leverage that WIS2 capability to publish its data in a way that will be accessible via FEMDI as well. So again, with EGVAP, there's no additional program requirement, noting that there may be some marginal extra cost due to the additional volume of sharing all of the ZTD data on behalf of EUMETNET. Next, please. So one of the questions that I've heard before is how the European Weather Cloud might be used to support deployment. So if we look back at the ESO case study that we did back in April, we talked about various different components of ESO being deployed on the European Weather Cloud. So here in green, you see a bunch of local components. So the ESO components are data availability, their data supply capabilities. And in yellow, you see a number of the community capabilities, API manager, shared catalog, and the message broker. We can see the message broker. In this case, I put Meteo France's logo by this and noting that it's deployed on the European Weather Cloud. This is where the global broker that Meteo France are providing in the pilot phase, that is deployed on the European Weather Cloud. Likewise, it may be that our instance of the shared catalog gets deployed there. Okay, we can come back to this slide if people have any more questions, but I'm aware that I'm running a bit low on time. So let's move on to the next slide. If we look to FEMDI implementation itself, the rodeo project will be running from 2023 to 2025 and we can see how work package 2 user interface largely is what we'll be using to deliver community components, and then work packages 3, 4, 5, and 6, amongst other things, we'll be delivering the local components needed to make real-time met data, warnings, and mobile infrastructure.
Jeremy, your voice and video is freezing.
Okay, can you now?
We can partly hear you.
Can you hear me now? Okay.
Yeah, a bit better.
Let me turn my video off. Okay. With Rodeo, we see a number of work packages which will be delivering community components and local components. Next slide, please. And the Rodeo team, when they put forward the bid, did a whole bunch of program planning. So we understand what we need to build and when we need to build it. Next, please. And in preparing for the next program period, 2024 to 2028, and the upcoming Rodeo project, Jane has been busy working with the teams to understand when we're going to deliver the data catalog, the message broker, identity and access management, and so on and so forth. So we have a good plan for when things are going to happen. It's worth calling out that the stuff in brown is Rodeo project work. The stuff in dark blue will be put into the EUMETNET next program period, and stuff in grey we don't believe are EUMETNET funded activities, and I'll pick on one of those in particular now. So next, please. The computation service, and I've talked about this as being future work. We know that data volumes are going to become so large that we can't effectively move data sets around. We will lose the ability to choose where we run our computation. So we have to move our computation to whatever cloud platform the data resides on. This is what we call data proximate compute. So the future, I think, must be multi-cloud. EWC, Azure, AWS, Destiny, etc. To make this happen, interoperability between clouds is essential. The FEMDI computation services aim to enable the execution of data-intensive compute close to the data, this is complex. And the technical architecture and the operating models are in their infancy. It's impossible to estimate costs for the program period 2024 to 2028, but we think it's likely that members and cooperating organizations will develop their own capabilities and charging models, such as the European Weather Cloud is already doing. Met Office, ECMWF and EUMETSAT are currently exploring cloud interoperability, and there's a link in the presentation if you really want to get a deep dive on that. We could provide a deep dive seminar, not to this audience, but to another audience, I'm sure. If there's interest, we can organize that. And just in general, is there appetite to collaborate more widely on developing these computation services within our EUMETNET community? And that is a topic for the breakout groups this afternoon. And with that, I think that's all I had to say. So next slide, please. I skipped over quite a lot of that quickly. The slides are available, and I would also refer back to the comms materials that have been provided by Jane and the team. So, Raw, if you would like to tell me if there are any questions.
Thanks, Jeremy. Thanks for this comprehensive overview of the FEMDI and the comparison with WMO activities, and also concrete examples on how this will be used in some of our programs. That's very good. I have a couple of questions myself, but let's start with to hear if there are any questions or comments from the participants. Please, so FMI, Tarja.
Yes, hello, and thank you for putting together this SWIS2 information and this FEMDI. It was very useful, but I would like to ask about the that FEMDI part, which will be part of the rodeo. So what is the status of the actual specification? So because it will be quite soon, we will start the project, and in order to go forward with the planning, so what is the status of having that specification requirements for that specifications?
So in terms of detailed technical specifications, many of certainly the parts which are relate to WIS2, they are reasonably well understood at the moment, and I can get in touch with your teams afterwards to describe what they are. If I could ask Jane or Mohammed if they have any comments on the level of specification that's going to be needed in order to kickstart the rodeo work.
Yeah, I'd ask Mohammed to come in on that if he's here.
Yes, I see.
Yeah. I'm just trying to find the mute button. Apologies. I think we have relatively high level information at the moment for community capabilities with the definition and what information is needed. And for data supply capability, however, we have quite detailed information now available for data publishers wishing to start any work. But for rodeo, considering that it's mainly focused on community capabilities, I think it will be useful, similar to what we have done with local capabilities, that the rodeo people who are going to work on these community capabilities to have a look at what information we have, and then we can organize a separate call to give them more information once they have questions. Because at the moment, it's difficult that what information people need. We realized after discussing with local capability people what kind of question they have, and then we prepare the material for it.
Yes, I think I would at this stage be interested particularly in this community capabilities, so the work package 2, so to speak. So yes, if you could send us the documentation you have, and we could have a look for that, and then maybe have a separate discussion based on those, based on the documents you could provide. Yeah.
Yeah, sure.
Yeah, very good, very good. So you handle that in a separate meeting. That's great. Then UK Met Office, Charlie.
Yeah, thanks, Raw. It's just 3 comments that I think I'll make, most of which will be obvious. So, having been on this track for some time, the Met Office have some benefits of experience. I would say that hopefully it is obvious, thanks to Jeremy's talk, that many of the things that FEMDI and Rodeo state we have to do, we're obliged to do anyway as part of wider WMO commitments. So I can understand that for some Met services this might look like a lot of work, but the alternative is to do it alone. So just to support the whole initiative really, and having a community approach to FEMDI, it is complicated. However, the alternative is to do all that complication on our own. So firstly, to support the overall initiative. From experience, a couple of points that I'll make. One would be around metadata. So for those Met services that aren't as familiar with this kind of approach, it's a call out really to recognise that the metadata management aspect, and this is really just ensuring that the data that we all have is well described with a third party thought given to it, is an enormous challenge for the Met Office. We are some years into this and still a long way from where we need to be. So in terms of work to start to schedule within each Met service, I would highlight the need to ensure that your data, our data, is well described, which, believe me, the Met Office's data isn't, is a big and important job, because discoverability and subscription are really just a function of being able to find what it is that you look for, and this will open our data up to whole new audiences that we simply can't expect to have the same domain knowledge and understanding that we have. And the third point is really about the future, and it's about the emergence of the importance of computational services. So Jeremy touched on it. It's not an immediate early topic to deliver, but certainly some of the work that we're doing with our partners is very different in terms of the data that they wish to consume from the Met Office. But simply, as we move further into the impact space, we're coming across customer after customer whereby we're going to have to provide some kind of computational service to use weather data against other data for things like machine learning algorithms to publish data that doesn't look like weather data. It looks like data that needs to know about the weather to generate it, but isn't in and of itself weather data. So again, just from the perspective of the Met Office, we're seeing all those things, and Jeremy mentioned them all quite starkly. So thanks, Rob.
Thanks a lot, Charlie. Yeah, 3 important points there. The first one I'll get back to, but first, Stefan from SMHI.
Okay, yes, thank you, and hello again, Jeremy, and thanks for this very careful done presentation. I had just one question related, something similar to what Charlie just said here about the data consumer here, because on one slide you defined it quite clearly that it was an entity such as an organization or individual or IT application that consumes data, but on some of the slides you also show the public, private sector and so forth. So I'm just wondering who will be the consumers and how many do you foresee, and will it be, let's say, open for everybody, or will it follow a similar path as Destination Earth, which you also mentioned, for the public sector to begin with, private later, and then maybe the full public? Thank you.
That's a great question, Stefan, and nice to see you again. Good to see you at INFCOM. In terms of who, the HVD regulation drives us to open the data to the public, to the private sector, and so on. So we know we have to make that happen. This is one of the key reasons we've introduced the API manager component, which we can use to make sure we can control. Somebody once said that the first day that your open data portal is successful is the last day it operates, because everybody wants to download your brilliant data. I don't know if that's the way it was in Met Norway when you started releasing yours, but so what we need to do is control the demand by giving people quotas or rate limiting or giving prioritized access to particular types of users. That's what the API manager does. WIS2 doesn't include one of those things, so this becomes a problem for global cache providers. But I think that we're going to be able to manage provision of our data to ourselves, to the public sector, to the private sector, to research institutions and the public by good configuration. Now, in terms of how many people, what volume of requests do we expect to see? This is one of the reasons that I asked our colleague Morten from DMI to share their experience about their open data initiative. Hopefully from that we'll begin to understand the processes that we can put in place to predict future volumes and control the control the burden that serving this data places on us. So let's come back to this question after Morten has had his presentation, but I hope that we can learn from their experience. And also, I mean, Roar is laughing, so he knows that he has some experience in this game as well.
Thanks a lot, Jeremy, and also to Stefan for asking that question. And yes, I can confirm that once the data become popular, you will have to start to learn how to manage the operational load, including priorities, different types of data caching, etc. So I have one question before we embark on the case studies, and that's related to the comment by Charlie on developing the local components and the need for us to do this. So we will discuss at the end of the session today how to collaborate on developing local components. But Jeremy, do you plan to have some special types of sessions with our technical people? Much of what you presented today, I think, would be very, very interesting to the technical personnel at the NMHSs.
So I think that the answer is a yes and a no. In our heads, we know we need to reach out and engage with the technical folk to help them understand what's coming, to help stimulate their development, either individually or in collaborations. Have we planned that? No, not yet. So yes, but we haven't actually got any dates in the calendars yet.
Good. So the message here, I think, would be that to all of us present, share for now the presentation by Jeremy with your technical folks, and then we will get back to them with more information at a later stage.
Yeah.
Good.